Okay, so quite a few of you will be doing little bits on standard form now. Some of you might have seen it already in science, things like that. Some of you will have used it before. You'll sometimes notice it on your calculator. But standard form is basically a way of either writing, so standard form is a way of writing really large numbers or really small numbers. Okay, and when we have them, we always write them in this form. A times 10 to the power of B. Okay, where this number A, or this letter A, this number, okay, is between 1 and 10. So it can be 1 and all the way to, but not including 10. Okay, so it has to be 1 point something, 2 point something, 3 point something, 4 point something, 5 point something, and so on, all the way up to 9 point something. It could be 9.9999999, but it can't actually be 10. Okay, they're always times 10, and then we've got this B. Okay, and this B can be positive or negative. Okay, now if I start just quickly going through, if I start quickly just going through what happens when we've got a large number, okay, so if I have something like, let's say 203,000. Okay, if I wanted to write that in standard form, I need my number, okay, to be between, said here, 1 and 10. So I'm thinking, how can I make this so that there's a number between 1 and 10? So it's going to end up becoming 2.03. I don't need to worry about the rest of these zeros. Okay, I need to write this one because it's a placeholder, but actually the rest of these I don't need to worry about. And then I'm thinking about how much this number is moved to have the decimal point go from there to there. Okay, so I literally count the spaces. I've got 1, 2, 3, 4, 5. So it would be times 10 to the power of 5. Because basically what that means is I'm doing 2.03 times 10 5 times. And if you think about that, so I've got 2.03. If I times it by 10, I end up with 20.3. If I do 20.3 times 10, I have 203. If I do 203 times 10, I end up with 2030. If I do 2030 times 10, I get 20,300. And if I do 20,300 times 10, I end up with my 203,300. So that is what I've basically done. Now, where it gets slightly trickier is when we end up with negatives, when we end up with these negative indices and negative powers of 10 rather than positives. A lot of people are really happy with these, and then we put out the negative ones and it kind of goes, oh my goodness, I'm not sure what to do anymore. Okay, because we see something like, let's have 3.6 times 10 to the minus 3. And a lot of people go, okay, well, it's got to be negative. It's got to be negative, but actually that's not the case. Times 10 to the negative 3, I could write that, if I think back to my laws of indices, a negative indice means 1 over. So I actually have 1 over 10 cubed. Now 1 over 10 cubed, because I make it positive, is actually 1 over 1,000. So what I'm doing is 3.6 times 1 over 1,000. Okay, now you don't need to know that. That is a little bit confusing for some people, but that's where it comes from. Okay, what you do need to know is how that changes it. Okay, so if I had this 3.6 times 10 to the minus 3, so I've got 3.6 times 10 to the minus 3, what I'm basically doing is I'm moving my decimal point 3 places the other way. So if I start with my 3.6, you can even, if it helps to start off with, create a table. Okay, literally have your units, your tenths, hundredths, thousandths, and so on. Okay, oh, didn't add an extra 0 there. Go back to what you did in primary school, because sometimes actually the whole idea of place value, that is very helpful. And I am moving it 3 places. Okay, so if I move it 1 place, that goes there, that goes there. So I now end up with 0.36. Okay, so that is if it was 10 to the minus 1. I'm going to move it again. And I'm going to get 0.036, and that's 10 to the minus 2. And I'm going to move it a third time, and I get 0.0036. Okay, and that is 3.6 times 10 to the minus 3. Now, what you do have to be careful with these is that you keep those zeros in. Okay, I did say when we looked at this one, and we wrote it the other way, I said you could get rid of those zeros or you didn't need to worry about them. These zeros here are placeholders, okay? And because they're placeholders, you need to keep them, basically. We need to still have them in. So if we look at another one, just to make sure it actually makes a lot of sense, if I wipe this board clean. So this time, if I have 2.85 times 10 to the minus 4. Okay, now again, you can do it whatever way you want. Some of you will start to find that once you do a few of these, actually, you can spot it quite easily. Other people do like to have the idea of your units and so on. So if I write my one, 2, 3, 4, 5. Okay, so I start off with my 2.85 here, and I know it's got to move 4 places. Okay, so I could literally, I'm not even going to have enough space here, think of what's going to happen. Okay, I could think of this and go 1, 2, 3, 4. So my 2 is going to end up there, which means my 8's going to end up there, which means my 5's going to end up, and I haven't even written a thing for it. Then all I've got to do is put my zeros in place. So I now have 0.000285. And what's really nice about this is you can work it the other way. You can count back and see, does that actually work? So if I want to get my decimal point here, I'm starting from here and I go 1, 2, 3, 4. Well, then it works. Okay, it works. It gets me back to what I originally started with. Okay, equally, if you're going the other way, okay, so if you are starting with a number, so if this time I'm starting with 0.053, okay, all I've got to do is think about where I want my decimal point and how I'm going to make that happen. So I want my decimal point to be there, so I need to go 1, 2 places. Okay, so I then know it's going to be 5.3 times 10 to the negative 2. When it is a 0.0 something, when it is less than 1, it will always be negative. Okay, when it's greater than 1, it will always be positive. So hopefully that helps. Have a look as well at how to calculate with standard form. And do ask if you have any more questions. Hope you're staying safe. Bye.